Today we are, like yesterday, how we went and reviewed circumference and then used that to find arc length measures. Um, Today we're going to step back and we're going to look at area again, and then we're going to combine it with, after review it, how to find the area of a sector of a circle. So let's see if I can clear a little of this out of the way so you can see a little bit better. There we go. So the first thing is a review of the area of a circle. Now remember, the area of a circle is how much basically two-dimensional space does it take up. So we're trying to calculate this um, kind of tan-looking area right here. And to figure out how much space this tan area takes up, we use the formula area equals pi r squared, where r again is our radius, just like it was in circumference. Pi again, that double-stemmed leg, and it equals approximately 3.14. In most cases, that's plenty of decimals. So we've got two formulas. The one we used yesterday, circumference equals 2 pi r, and then the new one today, but we've seen it before, the area of a circle is equal to pi r squared. Now, I do know that lots of times people give circumference as pi d, but the reason we frequently give it as 2 pi r is because it's so closely related to the area. In fact, see that 2? If that 2 were there, it's 2 pi r. So it's really closely related, so it does help us remember these two formulas when we use 2 pi r. So let's go ahead now and just find a couple of areas. Oh, this is just to reiterate what we're finding here. So when we're actually finding area, if this radius, for example, was measured in, let's see, we'll call each one of these little squares, we'll call it a centimeter wide by a centimeter. And so each one of these represents a centimeter squared. And I don't know, this radius is about 1, 2, 3, a little over 3 centimeters long. And when you calculate the area, you'd have to calculate how many of these square centimeters are in here. So what this formula does is it just cuts to the chase, and it says, hey, if you know the radius, I'm just going to approximate that radius as about 4. If you know your radius, by using 3.14 times that radius squared, let's put it in parentheses. If you do that math, it calculates how many little blue squares are in there. And I'm going to clear this there, and 16 times 3.14. So you end up with about 50.24. And if I call them each a centimeter squared, there would be about 50 of them in there. Now that's all ballparked here, buddy. My radius is a little bit big. I could see my radius 1, 2, 3. It's probably closer to 3.5 for radius. So there's not exactly 50 in here, or 50.24, but it's approximately equal to that. So pi r squared figures out that, how much surface it covers. So here in our example, find the area of a circle with a radius of 2.5 centimeters. So let's draw a quick circle here. The radius of our circle is 2.5 centimeters. They just want the area. Area is pi r squared. So 3.14 times our radius, 2.5. We're in centimeters here, squared. So grab your calculator. Pretty straightforward. 2.5. Make sure you take care of exponents first. So you square it first, and then multiply times 3.14. And so it is 19.6 centimeters squared in area. So you could put those little squares, about 20 of those squares it would take to fill up that circle. Diameter of a circle. Let's see here, we'll use that. diameter of a circle with an area. So this time the area is given to us. 13.1 square centimeters, so we write that centimeter squared like that. So we're going to have to use the area formula again. Area equals pi r squared. But this time we know the area. We know what pi is. We just don't know what r is. Now when you go to solve this, identify what kind of equation it is. This is quadratic. This is an r squared equation. Okay, we could get it equal to 0 and try to factor it. There's no sense in doing that though, because there's no r to the first power. Remember, standard form is ax squared plus bx plus c. All we have is the x squared or r squared term. So we're going to isolate the r squared. We'll just divide both sides by 3.14. Again, we go to our calculator. 113.1 divided by 3.14 equals, and so r squared equals, that is that, and 36, we'll just call it 36 even, it's 36.01, and now you square root both sides. That's one of the first ways we learn to solve quadratics. Now, when you solve it, you do get plus or minus, but you can't have a radius that is negative, so this radius must be 6 centimeters, like so. Yeah, that looks about good. So that's it for that. Now, let's go ahead and find what we call sectors. A sector is just a section of a circle. You can see it right here that is delimited by 2 radii marked off by a angle in the center of the circle. So when we're asking for the area of a sector, we're not asking for the whole circle, we're just asking for a part of a circle that is marked off by an angle. To figure out the area of a sector, we do it very similar to how we found arc measure yesterday. We basically find the ratio of the area of the sector to the area of the circle. That's what we were just practicing. It has to be equivalent to the measure of the sector's angle to the entire circle, which is 360 degrees. And just like yesterday when we were trying to find the arc length here, they've multiplied both sides times pi r squared to get this final equation. And you can see the pi r squared now is on the right-hand side. So essentially this is find the ratio of the sector angle to the entire circle, 360, and take it times the entire area. And so let's say this is, half the circle, 1 over 2, then it'd be half of the area of the circle. It's very similar to yesterday's. So let's find the area of our sector here. The area, and this time I'm going to mark it, area of UTV, and I'm using it as a subscript, so I know. We could also write something like area of red and use red for a subscript. In fact, I'm going to use that instead. Area of red is equal to, well, let's find out how much of the circle it is. So this is the measure of the angle UTV over 360 degrees, the measure of the entire circle, times 2 pi r, the area. Now, I think that notation is a bit confusing, but what you're doing is you're finding out the ratio of the circle you have. You have 70 degrees out of 360. And note, I did the wrong little formula there. We're doing areas, so I have to take it times pi r squared. So it's the proportion of the circle I have, 70 out of 360, times the whole area of the circle, and that just leaves me the little red region. So we'll just put times pi. See, our radius is 8. See it right there. So times 8 squared. So let's do a little cleanup here before we get out the calculator. So that simplifies to 7 over 36 times pi times 64, 8 squared. So 7 times 64 times pi over 36. Let's go ahead and get a decimal value. It didn't ask for it as in terms of pi, so we'll go 7 times 64 times pi, 3.14. There's my numerator. And I'll just divide by 36. So it is about 39, inches squared. And I know it's inches because my radius was measured in inches, and I have to use inches squared because remember we're talking about how many of those little squares would it take to fill in that red region. Right? So again, the way I'd like you to look at this is basically you're finding the area of the entire blue circle. 3.14 times 8 squared. Let's go ahead and throw that in. 8 times 8, that's my 8 squared, times 3.14. So there's the area of the entire 201 area of the entire circle. And then when you want just the red region, you figure out what part of the circle it is. It's 73/160ths. And you just take it times that whole area. And that just gives you the portion that you want the area of. Let's go to our next one here. Find the area of the red and the blue regions. Let's do the red one first. And I'll go area of red is equal to, now that's 120 out of 360 of the circle. And then you want to take it times the area of the entire circle. So that's the proportion of it you have, or the ratio of it you have, or part of it you have, times the area of the whole thing, and that would be pi times r squared, but r is just 14. So that's going to get you the area of just the red region. Let's grab our calculator. Let's go 14 squared, 96. So taking care of that, take it times the 3.14. And I didn't get it in there. I was at 196 times 3.14 equals. Then we got to take it times 120 because I've done the pi. Now I got to do the 120. So there's my entire numerator. And then lastly, I divide by 360. And I get an area for the red region of about 205. And our units are feet squared. Let's do the area of the blue. Should have color-coded this. The area of the blue is going to be the exact same thing, except the blue, if the red is 120, remember a circle has 360 degrees in it. 120 is the red one, so that leaves us 240 degrees out of the 360 left. That's the blue region's percent of it. Take it times pi r squared again. The area of the whole thing didn't change. All right, well, we just did clear things here. We did 14 squared is 196 times 3.14 times 240 equals, and then divide by 360. And I get 410.3 feet squared. So the red one and the blue one in total, that looks like it gives us a total area of 615.3 feet squared. Now we didn't have to find that out, but I'm doing this as a check. because the area of the red plus the area of the blue should equal the area of the entire circle. So the area of the entire circle D would be equal to pi times r squared. So 14 squared. Let's find the area of the whole thing and see if it equals our calculations. So that's 196 times 3.14 equals 615.4. So because of rounding, we're off by just a little bit, but we can see we're fairly confident that those are our correct answers. All right, your homework is just a Google form. You have to calculate a couple of areas of entire circles and then a few areas of sectors.